Yes guys, welcome back to Pure Math School, and today we're going to look at the sixth part of the introductory work of pure mathematics, and that's the trigonometrical ratios of acute and obtuse angles. So let's start straight away. Uh, when we first need to know about acute angles and obtuse angles. Acute angles are those angles between 0 degrees and 90 degrees, and obtuse are those ones between 90 degrees and 180 degrees. So that's it, and let me give you some thing that can make you recall that. Let's consider that here to here, that's 0. This is a starting point, 0 degrees. Here we have 90 degrees. When you come here, we have 180 degrees. Here we have 270 degrees, and here we have, or we'll come back to here, when you go around, that's now 360 degrees. And so acute angles lie here, reflex angles lie here, obtuse, obtuse 90 to 80 degrees, between 90 and 80 degrees. Then reflex here, reflex angles are angles between 180 and 360 degrees. Let's say reflex, acute, obtuse. So for today, we're going to look at trig ratios of acute and obtuse angles. And let's start straight away. Let's consider this as we introduce it. Let's say this angle is there, and this angle here, this is a right angle triangle, which that's this 90 degrees, and the sum of all these add up to 180 degrees. So for us to get this angle, we have 90 here plus a here plus a, let's just give that maybe x, giving us 180 degrees. A triangle adds up all these angles to 180 degrees. So we want to get that x. That means we are going to take 90 the other side by subtracting it from here, minus 90. Then we also remove a from there to bring it this side by subtracting on both sides as well. Okay, so that here a would cancel and 90 would cancel, so that we have that. So we have x given us 180 minus 90 is 90 degrees minus a. So that angle is actually 90 degrees minus a, that angle x. So now we're going to give this, let's give this side a, this side b, this side c. Now trig ratios we're going to be getting now. Now we need to get the sine, cos and tan. We always have. I'm going to show you what it is, and we need to first introduce this. We need to get the sine of a, cos of a, tan of a. Sine is now I'm going to show you how we can get that. Let's use something to make us recall the formula, because sine is given by opposite out of hypotenuse. This is the opposite. Hypotenuse is that. When we are at this angle, you need to be careful of which angle is adjacent, which side is the adjacent, and which side is the opposite. When at this angle, you just consider this 90 degrees. If you're here, you consider that the angle we are considering, which is angle A here throughout, is adjacent to that 90. That makes that side where A is lying, this base here, to be the adjacent, since it's adjacent to this 90. Then this side of which angle A, which is this side which is opposite to this angle A, is considered the opposite side. So that's why we say sine is opposite out of hypotenuse. This is the hypotenuse, the slanting one. Cos is the adjacent out of the hypotenuse. Tan is the opposite out of the adjacent. So let me give you a brief formula that can help you recall that. SOHCAHTOA. So here you know that sine opposite out of hypotenuse, cos adjacent hypotenuse, tan opposite adjacent. So now we see that our sine A is opposite hypotenuse, so that we have opposite here. Since this side is opposite to this angle, that A becomes our opposite. And now the hypotenuse is C, which is the slanting one. Cos is given by adjacent, which is this, the adjacent to 90, so that side becomes our adjacent out of hypotenuse, which is still C. Our tan becomes opposite. A is still opposite to that angle, that side, so it's our opposite out of the adjacent, which is B. I think we have understood that clearly. Now let's see. We observe that tan A equals to A out of B, which is equal to A out of C out of B out of C. You see that this is the same as actually having A out of C times C out of B. If you remember, if you divide in two fractions, you get the other one. You multiply and you make the other. You multiply one and get the reciprocal of the other when you're multiplying. So that C comes to becoming A out of B, which is actually A out of C is sine A, and B out of C is cos A, which implies that our tan A is given by sine A out of cos sine of A. Yep. Now we are done there. We need to get, now let us shift to this angle, that 90 minus A. We are still considering this here. We have here 90 minus A, that angle. So we are going to consider now, let's see, sine of 90 minus A. So from this here, we saw that sine is actually opposite that of hypotenuse. So since it's opposite that of hypotenuse, that means, but for this case, we need to observe that our opposite has changed here. Since we have this angle here, so the side opposite to this angle is actually this side. So this becomes our opposite, which is B out of the hypotenuse, which is still C. So our sine of 90 minus A is actually B out of C, because B this time is opposite. The side B is actually opposite to that angle. Now our cos of 90 minus A is given by adjacent. Remember, cos is adjacent over hypotenuse, so we're going to have our adjacent. This angle is now adjacent to 90, so that makes that side our adjacent. Hypotenuse is the slanting one, which is A out of C. Then tan of 90 minus A is our opposite, which is now this side. That angle is now opposite to this side, which is B out of the adjacent, which is A. So that we have B out of A. Okay, so that here we will still realize that our tan 90 out of A is still the same as sine 90 minus A out of cos of 90 minus A. From this, what we looked at this side, use the same thing. You can observe, compare also the other side, and you see that it's still the same thing here. And now let's make some note here. Sine, let's say sine of any angle, let's say A, is given by cosine of the complement. Cos of A is given by sine of the complement. Then tan of A is actually sine of A out of cos of A. Those are the observations we can make. Let me explain to you what complement means. This one I would mean that is cos of 90 minus A. This one I would mean that is sine of 90 minus a. If you observe this, you're observing, sorry, we are observing that sine a, we are saying that sine of the angle is cosine of the cosine of the complement, which is this, which is a out of c, and you see also here a out of c. This is same as cos of 9 of a, I mean. Then here is the same as sine of a. You've observed this side, you find that sine of a is a out of c, or which is here is a out of c is cos of 90 minus a. And for the case of the cos of a, here is the same as is b out of c. Sine of 90 minus a is b out of c, which is the same as cos of a this side, which is b out of c. So now we mean, you know what complementary angles are? Complementary angles are angles that add up to 90 degrees. So now if you have two angles that are, let me say, if you have a and maybe another angle x, this a and x must add up to 90 degrees. Okay, so if you now have 90, that means our x is actually 90 minus a, which means now 90 minus a is a complement of a, which is x is the complement of x is 90 minus a, so which is actually then our complement of a is actually 90 minus x. So complementary angles add up to 90 degrees. So complement of a is 90 minus a. Complement and that's all I can say about complementary angles. They add up to 90 degrees. So complement of a is 90 minus a. That's all I can say about that. And we can now move on to the next thing. That is, let's look at particular angles. Sorry. That these ones we mean 30 degrees and 60 degrees. Okay. Now for this case, we consider an equilateral triangle of sides 2 units. Now we are considering an equilateral triangle of sides 2 units. You know, equilateral triangles have equal sides. I mean, all the sides are equal. Let's consider that it's equilateral, that each side, like all the sides are equal, 2 units, 2 units, 2 units, that, and here. But now let's drop a perpendicular and divide it into 2, so that we have a height there. I'm trying to look for a height, I mean. So let's say this 90 degrees perpendicular to the base. Now let's say now, that means if this perpendicular dividing the base into 2, that means this side is 1 unit, here is also 1 unit. Let's try to get our height. Let's consider this. So that means, you know, from Pythagoras theorem, here we're going to have for us to get this, you know that this squared plus this squared must give us that squared. Let me say this is a, this side is a squared plus 1 squared should give us 2 squared. Now a squared is going to be 4 minus 1, because 2 squared is 4, 1 squared is 1, so that we have a being given by a is given by root of 3. If you take square on both sides, a squared equals to 3. I mean, take root on both sides, you get a being given by root 3. So that a is actually root 3. So now we have that. We can now try to say that, you know, equilateral, if all these sides are equal, you know, if you have all sides are equal, 2, 2, 2, that means even all the angles are equal. So we have 3 angles. Since they are equal, we just divide by 3. That means the sum of the angles here, that's 180. We divide by 3 to see each angle, since they are all the same. So if we divide by 3, I think 180 divided by 3 will be 60 degrees. So you find that each of these is 60 degrees. But this one, since divided into 2, this side will be 30 degrees and the other also 30 degrees. Okay, so now let's start with 30 degrees. We'll find that sine of 30 degrees is going to be given by, oh, remember we looked at Hasokato, this, okay, sine is opposite out of hypotenuse. Since we are here on 30, our opposite becomes this, which is 1. Hypotenuse becomes that which is 2. Okay, I explained that earlier. Then cos of 30 degrees adjacent out of hypotenuse. So here we're going to have our adjacent. Since 30 is here, this 30 is adjacent to this, which makes that side the adjacent side, which is root 3 out of the hypotenuse, which is 2. Then tan of 30 degrees is the opposite out of adjacent. Opposite to this angle is this side, which is 1 out of adjacent, which is root 3. 1 out of root 3, which is also the same as root 3 out of 3. If you rationalize, if you remember rationalizing starts in our previous I think our last video. So we have got that for the case of 30. We are done. Let's shift to 60. Sine of 60 degrees is going to be, now we have sine, we are now this time here, sine is opposite of our hypotenuse. So now we have our sine here, our angle 60 here, but our opposite side is actually, that side is the one opposite, which makes that root 3 the opposite out of hypotenuse, which is 2. Then cos of 60 degrees adjacent now becomes this, since adjusted, this 60 is adjacent to 90, which makes it 1 out of hypotenuse, which is 2. Then tan of 60 degrees will actually be, or opposite, this opposite to that, which is root 3 out of the adjacent, which is 1, which makes it only root 3. Okay, I think that's for the particular angles we're done. Let's take a look at one of 45 degrees, and we need to be mastering all this, because with time you need to be having this at your fingertips, and you just know through this, or you can derive just like using this, so long as you know. The most important ones you have to actually always master or even recall are these ones here, these observations here. They will help us in, especially when you go deeper into trigonometry. That's our video, that 4.1. When you reach there, when you start looking deeper into the trigonometry. Now we go to 45 degrees. And for this case, we are going to consider a right angle triangle still. Oh, I don't know why it was. Okay, just ignore this. Sending here, right angle triangle of here, each side 1 unit. That means which we will be having this 45. Even here is the same, 45 plus 45 plus 90 gives us 180. Then that from Pythagoras theory you can get that. You have been seeing that many times. Think you can 1 squared plus 1 squared must give you that square. You can, if you calculate that, you'll get that from Pythagoras theorem. So now we can see sine of 45 degrees. We're going to have opposite from our Soka tower. Sine is given by opposite out of hypotenuse, which is 45 is there. Our opposite is this. Even if 45 was here, you would still get the same thing, because this is also 45. Let's use that for this case. Opposite is this, which is 1. The hypotenuse is root 2. If you rationalize, you're going to get root 2 out of 2, which these are all the same. Then we have cos of 45 degrees. Cos adjacent out of hypotenuse. Adjacent is still 1 out of hypotenuse, root 2. Still, if you rationalize, you get root 2 out of 2. Then tan of 45 degrees, it's going to be given by opposite, which is this. Opposite to that is this, which is 1 out of adjacent, which is 1. It gives us 1. I think for 45 we're actually done. Even that's all we need to know. We just have to know these ratios, these trig ratios for these. Now let us take a look at 0 and 90 degrees. 0 degrees and 90 degrees. Okay, here. By the way, here we one thing. What makes this side? Let me explain to you. What makes this side 1 1 is an isosceles right angle triangle. This an isosceles right angled triangle. Because you might be having the question that why is it 45 degrees? An isosceles right angle triangle has each side one unit and what angles are 45 degrees. Okay, let's continue. For this case, we're going to consider a right angle triangle, and we just try to name. Just now, we try to create conditions of 0 degrees and 90 degrees. Consider right angled triangle. Okay. Oh, let me draw it here. There's here 90, and that angle also is needed. You say here x 90 sealed from the same pi. If you combine these angles and you calculate, you get that. For that, now let us name here A, B, C. Okay, that should help us. Now I think we can try to start getting sine of 0, cos of 0, tan of 0, then that. But now we need to assume. Remember one thing about this, we need to know that now that means for us to create a 0 degrees, we can start from here. So let's start with 0 degrees, and for that 0 degrees we will need to make sure that x is 0. That means we will look at condition when x approaches 0, and we see what happens actually. Start straight away. For 0 degrees, and we're going to be using this diagram, this right angle triangle of ours. As x goes to 0, we'll see that BC will also reduce, b tending to 0, and this side, this length hypotenuse AC will, after reaching this point, will actually be the same length as AB. That means even AC will tend towards AC will tend to be to AB in length. So let's say as x approaches 0, that's to help us get that 0 degree. AC approaches AB and BC approaches 0 in length. Okay, x in an angle approaches 0 in degrees, and AC approaches AB and BC approaches 0 in length. That's, if you see here, this one, if this angle keeps reducing slowly, it will reach 0, and this length AC will also become this length AB after finally resting here, and this length ABC will also reduce until it's 0. That's if x tends to angle 0. Now let's put that in mathematical way of writing. As x tends to 0, which is written mathematically as this, written as x tends to 0, that arrow meaning tends, we'll have AC will tend to AB and BC will tend to 0. Okay, so now let's now check for our sine of x. What's our sine of x in this right angle triangle? Sine of x, remember from our thing here, so that easy way of memorizing. Sine is opposite out of hypotenuse, opposite hypotenuse. So x is here, this angle, the opposite side is that makes BC our opposite, then our hypotenuse is actually AC. So now we're going to have BC out of AC, but we said as x tends to 0, now we put that condition, we have BC tending to 0. That implies that sine x will actually be 0 out of AC, which is 0. So as x tends to 0, you realize we'll be getting sine 0 being that, and sine 0 is actually 0 as for that case. How about our cos of x? Cos x is adjacent from this. Cos is adjacent out of hypotenuse. So we're going to see x is here, are adjacent. This angle is adjacent to 90, so that makes this side are adjacent, which is AB. Hypotenuse still AC. So actually it's AB out of AC. But as x tends to 0, the AB and AC, here we see that AC will tend to AB. So as AC has tended to AB, that means we now replace AC with AB here. So we'll have our cos x given as AB out of AB, since our AC is replaced by AB, which gives us 1. So actually when x tends to 0, our cos 0 now becomes 1. Now we go to tan. Let's look at tan. Tan x, you know tan is opposite out of adjacent. Now from this, tan x is here, opposite to that is that BC out of adjacent, which is AB. So it's actually BC out of AB. But as x tends to 0, we will have our BC tending to 0. So what does it mean? We're going to have our, thus tan x is going to be given by 0 out of AB, which is 0. So as x tends to 0, tan 0 will now become a 0. Now we are done for the case of 0 degrees. Let us go to 90 degrees. If you remember that from what we derived earlier on, our tan x is sine x out of cos x, from what we derived earlier on in this video. So we have tan x, our sine x was actually, what was our sine x? Sine x was 0 here, out of cos x, which was 1. This goes to 0. That's why we are getting actually tan 0 here, if you see that. So let us go for 90. Similarly, we're going to use the same conditions. Similarly, as x tends to 0, we have same AC still tending to AB, and we have our BC tending to 0. But we have to remember this angle now. This angle, as this tends to 0, we are having a BC going towards this point and this line coming to rest here. That means at one point this line here would just be like that, like this base. That means 90 minus x would tend to 90 degrees only, because at this point it's going to keep expanding until what? It becomes 90 degrees. At this point, this line will at one point like this. That will make it 90 degrees to the horizontal, if you can really see that from that diagram. So we also have here that 90 minus x would tend to 90 degrees. So that's how we are going to create our 90 degrees in that. Then we can now start getting our sine of 90 degrees. Sine of 90 minus x is going to be given by opposite out of hypotenuse here. Sine opposite out of hypotenuse. So since our sine is opposite, we have that angle here. This time our opposite side is this, which is AB. Okay, it's that angle coming down. So it's actually that angle which is going to be opposite to this, which is AB. Hypotenuse is still AC. So we got AB out of AC. But we have, as x tends to 0, our AC will tend to AB, right? AC will tend to AB, and 90 minus x will also tend to 90 degrees. What does it mean? That means I assign 90 now. Can you see this now? Let me go the other side. That means 90 degrees, sine of 90 degrees now. After 90 minus x tending towards, after x tending to 0, 90 minus x will tend towards 0. Towards 90. It's actually going to be now, and remember our AC has gone to AB. That send it towards AB. That means actually AB, sine 90 will become AB out of AB. Okay? AB out of AB, which is equal to 1. So that's how we get sine. Let's check for cos of 90 degrees minus x, which is adjacent out of hypotenuse. Here, adjacent is this side now. So hypotenuse is that is BC out of AC. So we have BC out of AC. But as x tends to 0, BC tends to 0. 0 in units, not in degrees. And 90 minus x would tend to 90 degrees, implying our cos of 90 degrees will now become BC, which is 0 out of AC. So that we have 0 for cos 90. Now we check on tan degrees, tan of 90 minus x degrees. So same as opposite out of adjacent. We have the angle here. Opposite will be this, adjacent with that. So AB out of BC, that's tan opposite out of adjacent. So it's actually AB out of BC. But now, as x tends to 0, we're going to have BC. This BC will tend to a 0 in units. So we have here AB out of 0. That's after R90 minus x has tended to 90 degrees. So that means our tan 90 degrees will be that. And any number divided by 0 is undefined. If you press in a calculator, it's going to bring syntax error. For that case, doesn't mean it actually can't be found, but it's some number which we remember. As you divide a number by a bigger, let me say if you have 1 out of 2, and you compare with 1 out of 4, 1 out of 2 is 0.5, 1 out of 2 or 4 is 0.25. Which one is bigger? 1 out of 2. Now if you come to 1 out of 1, you'll have 1. Okay? Now that means I think it increases at the denominator, reduces. Then 1 out of 0.5, you'll find that it's bigger. Okay? Because it means 1 divided by 5 out of 10, which is same as 1 times 10 out of 5. So you see it's actually 2 this time. It's becoming bigger and bigger. So now we assume that since 0 is actually a no number now, that means a number out of a very small number is actually a very big number that we cannot actually now get. So that would mean we put it infinity, something bigger on the positive side of infinity, which means bigger. We're going to put that infinity, meaning that it's too big. We can't comprehend, we can't know it, but just know from this concept, that means a number out of a very small number, which is to the point of 0, is actually infinity, too big. That's what I mean by that. So I think now I think for today we can stop there. Let me just give you some brief summary. We have here angle, sine, cos, tan. Okay, 0 degrees, 30, which follows 55, 45, 45, then 60. Let me go to 90. This is a summary. Sine of 0, according to what we had been finding, I think it's 0. Then cos of 0 is 1. Then tan of 0 is 0 out of that, which is 0 out of 1, which is 0. Sine of 30, I think we got half, according to what we derived earlier. We need to recall this because the things have to be on our fingertips. Sine will come when our calculations will be a lot. We just need to be having these simple ones on our fingertips. Then cos of 30, I think root 3 out of 2. Yup. Adjacent hypotenuse. Yeah, root 3 out of 2. Then here would be 1 out of root 3. Okay, then sine of 45 is 1 out of root 2, same as cos of 45, 1 out of root 2, which makes this actually 1. That means tan of 45. And cosine of 60 is the same as cos of 30. How do I remember that? That's which is actually root 3 out of 2. Then cos of 60 is a half, same as sine of 30. Then this will actually be root 3. Tan of this is root 3. Then 90, sine of 90 is what did we get as sine of 90? I'm forgetting 1. Then here was 0. Then this was too big. In summary, that's all we have for today. Thank you for coming to this channel. Please like, subscribe, share, and comment. Thank you. See you in my next video.